A very good day, students. Hope you are all doing well. So in today's lecture, you will see a case study on diesel engine. So particularly, this case study will be discussing about ignition system of diesel engine. So you would have studied the basics of engine. So just giving a quick recap, there are probably two major types of engines. One is external combustion engine and another one is internal combustion engine. So primarily we will be focusing on internal combustion engine. So almost all the vehicles today run on internal combustion engine. So there are two major categories of internal combustion engine. One is SI engine and another one is CI engine. So what is SI engine is spark ignition engine. CI is compression ignition engine. So a spark ignition engine works on the principle of spark ignition. So here, as the name indicates, the spark is ignited. So what the process done here is that, take the case of a 4-stroke engine. In the first stroke, there will be suction. In the second stroke, there will be compression. So during the compression stroke, a spark will be ignited. This spark will ignite the air-fuel mixture and combustion takes place, and then comes the power stroke and the exhaust stroke. So another type is compression ignition engine. Here there will be no spark plug. So here what happens is that suction takes place in the compression stroke. Due to the compression, heat is generated. So that heat is sufficient to ignite the air-fuel mixture, and then same process, power stroke happens and then the exhaust stroke. So it's a two major type of ignition systems. So SI engines are used in petrol engines, or SI engines uses petrol as fuel, and CI engine or compression engine uses diesel as fuel. So SI engines or petrol engines are predominantly used in two-wheeler as well as cars, four-wheeler cars. But if you take larger machines or larger engines, say the case of a diesel engine in a train or a truck or a ship. So most of the ships run on diesel engine. Some may run on coal and others on nuclear fuel, but predominantly most ships run on diesel engine. So high power and high torque can be obtained through diesel engines. So that's the reason we are using compression ignition. Preferred mode is compression ignition. So in a compression ignition engine, what happens is that the fuel will be sprayed with high pressure. So then it ignites. But the efficiency of the system depends upon how much fuel is sprayed. So if too less fuel is sprayed, then you will not get good combustion or adequate combustion. Adequate power will not be obtained. If too much fuel is sprayed, what happens is that there will be incomplete combustion. So there will be not complete combustion. So complete combustion will not be obtained. So what happens there is that carbon monoxide will be liberated. So black smoke coming from vehicles. So optimum preferred spraying of fuel is required. So for that, a new technology is introduced, which is called as common rail direct ignition system. So this is a high pressure system which uses nozzles and valves to spray the fuel. As you can see here, there are different. 1 minute, I will move my video. Yeah. So here different components are used to deliver the fuel at a high pressure. So first one is a fuel pump. So what's the function of pump? So pump produces high pressure fluid as output, and then there are the fuel rails. Fuel rails are the tubes through which high pressure fuel is distributed, and then comes the injector. So injectors inject the fuel into the air fuel combustion chamber. So this is injectors. Here injectors is plural because it may be used in case of multi-cylinder engines. So if you go for larger engines, it is predominantly multi-cylinder engines. So how the process takes place? Fuel will be compressed to high pressure and it will be sprayed to the adjacent cylinders. So that is the process of compression ignition engine. So what are the benefits of this CRDI process? The reduced emissions. Since optimum fuel is being sprayed here, emission will be reduced, and also higher power will be obtained. Since the fuel pressure is at an optimum or high level, adequate pressure will will be released, and also improve fuel consumption, better response of the engine. So these are the difference between the common rail and a traditional ignition system. As you can see, high fuel efficiency, lower emissions, and higher power can be obtained. So there is another technology called as multi-point fuel ignition system. Here, this MPFI or multi-point fuel ignition system is somewhat lower in cost compared to CRDA engine. So what happens in this MPFI engine is that multiple injectors will be placed inside a single cylinder itself. For single cylinder will be using single injector, but here multiple injectors will be used so that it will be sprayed at multiple locations to increase the fuel efficiency. What are the advantages of MPFI is that it is lower cost and easy installation, but to compare the CRDI engine, since it is a pressurized fuel, the performance will always be better. What are the future technologies for this CRDI engine? High pressure injection. More high pressure injectors can be used to increase the fuel efficiency further, and also sensor technologies can be used. Nowadays all the engines run on sensor technology, so sensors can be utilized to calculate the fuel requirement and spray the fuel. And also hybrid diesel engines. So hybrid diesel engines, they are integrated with battery so that more power efficiency and energy efficiency is obtained. So these are the benefits of the CRDI engine. So to sum up, CRDI is a common rail direct ignition system. Here, a common rail system with high pressure injectors is used to spray the fuel into the ignition chamber to get higher fuel efficiencies. So hope you understood this topic. So we'll see in another topic in the next video. Thank you, students. Have a nice day.